Okay, we're going to attempt to review some of the net ionic equation writing skills that you're going to need. This is the assignment from Thursday for those that were absent. Anytime we're going to write a complete ionic equation, we need to first find the balanced molecular equation. So we have to look at our reactants and decide what our products are going to be. And we have a salt, aluminum hydroxide, reacting with an acid HCl, and we're going to be a double replacement reaction where aluminum is with chloride, and it's an ionic compound, so we look at the charges to decide what the subscripts are going to be. And we're also going to make hydrogen bond with the OH and make hydrogen hydroxide, which is essentially water, and balance the equation. We have 3 hydroxides here, 3 chlorides there, so we're going to have 3 chlorides there, which makes our 3 hydroxides and 3 hydrogens balance out nicely. So there's our balanced equation. And now phases. This is step 1, so to speak, of the steps in your notes on how to write net ionic equations. Step 1 is to get the balanced equation. Step 2 is to decide what is going to dissociate into ions and what will not. So in other words, we're going to decide what our phases are. Aluminum hydroxide, if we go to the solubility table, we find out aluminum hydroxide is not one of our 6 strong bases, and hydroxides are insoluble, so this is going to stay together, so this is going to be considered a solid. So we're going to write that as a substance that stays together. We're not going to separate, dissociate out. Hydrochloric acid is one of our 6 strong acids, so it will be aqueous and is going to separate, so we have our coefficient that's going to say 3 hydrogens, and we're also going to have 3 chlorides in the aqueous form. And then on the right side of our yield sign, we're going to now look at aluminum chloride. Well, all chlorides are soluble if you look at your solubility rules. And so if that's soluble, then this is going to be a soluble salt. Soluble salts are strong electrolytes. Strong electrolytes are the only substances that we dissociate. So we're going to end up with aluminum ions present, and we're going to end up with chloride ions. We're going to have 3 of them. Not subscript 3, but a coefficient 3, and they're aqueous, dissolved in solution. Water is a molecular substance. It's if you want to look at it as being a weak acid because the H is at the beginning. It's not one of our 6 strong, so we're going to keep it together because of that. Or you can say it's a base. It's got hydroxide in it, but it's not one of our 6 strong bases, so we're going to keep it together for that. Or you can just realize, hey, it's water, and water is a molecular substance, and we're going to write it as a liquid phase. So now, step 2, we look at our total. This is a total ionic equation. And we notice that we have Cl minuses, 3 of them, aqueous on both sides. So just like in math class, we can subtract or factor out, so to speak, those like terms on each side of the equal sign, or in this case, the yield sign. So we do that, those spectators are gone, or spectator is gone, and we're left with aluminum hydroxide, solid phase, reacts with 3 hydrogen ions, aqueous phase, producing aluminum ion, positive 3 ion, aqueous phase, and spectator does not get included, did not carry my 3 down, 3 HOHs, liquid phase. And so there is my net ionic in its entirety. And if I asked what my spectator is, I would know my spectator is a chloride.